right, and we are live. So, today is April 22nd, and I first want to start by explaining it was all set up. I had the stream all hooked up and cameras and this and that. So, and then I was ready to go at 9, and all of a sudden at like 8:58, my Wi-Fi just shut down. So I tried on my other computers, on my phone. I went downstairs to the living room where my router is. I reset the whole thing. Nothing. So it was at that point where I sent the message through my phone to the Google Classroom that things were going to be delayed a day. I was just going to do it right on my phone, but the big data, for some reason, the reception isn't all that great. And, it is what it is. So we looks like the video is a little choppy. Let me see if I can fix that here. All right, so just screwing around with the settings here. I hate that this is so complicated, but anyway. All right, so anyway, yeah, I was going to just do it on my phone yesterday, but it is what it is. Oh, Tina's here. Hi, Tina. Nice to see you. I hope you're safe out there in the world while I'm sitting here in my favorite green hoodie ready to teach. Anyway, so I was just going to do it on my phone, but the reception is terrible, so I wasn't able to really get enough reception to even do it. So I just sent the message. Yesterday was our breather day. Today is going to be new stuff for both honors and non-honors, and we're going to start with the non-honors. So, non-honors guys, so far at this point we've covered the 5 types of reactions. We talked about the patterns. You were able to predict the products, and you were able to balance them. How's it look now, Connor? I changed something. So I changed the setting, so it looks like it might be a little better, at least for me. Yeah, my test screen seems to be going a little better. I changed the bit rate, so I hope that does it. Anyway, so that was why we didn't do anything yesterday, and I apologize for that. But today we're moving forward. Now, for non-honors, today we're going to specifically look at singles. And the single replacement reaction, we're going to do a quick recap on that. All right. Connor, how's it look now? It seems to be better for me at this point. I'm looking at different screens, and it seems to be a little better. But good. Okay, cool. I'll leave it at that setting. I tried to get a better quality, but for some reason, whatever. So here we are. Let's see. Let's see if I can change this down here. Huh. I guess I can't change that. All right, whatever. Let me try this thing. Nope, can't do that. Okay, we're stuck with the quality the way it looks now, but Connor, you say it's fixed. So here we are. All right, let's talk about doing singles and only singles. Okay, so we're going to be talking about singles real quick. Let's do a quick recap. A single is when you have a metal plus a diatomic. All right, and when those two interact with each other, you're going to get a result that is from the crisscross. Okay, now we know how to do all that stuff, but a quick example would be something like sodium plus chlorine. Now, chlorine is diatomic, so that's why there's 2 of them. And then you do the crisscross between sodium and chlorine, you get sodium chloride, and the last step would be to balance. So that's where we're at. That's what we've done. Now, what I'm going to show you today is actually going to save you some time because not all singles are actually going to happen. Some singles are going to be a result of no reaction. So let's take a look at a screen that you would have seen in the PowerPoint. Now, this screen here is a list of 13 metals. What I would like you to do is jot this down or pause the screen or whatever you got to do. I'm going to keep going. Being that it's a live stream, you can get caught up. So if you pause the screen, jot this down or take a screen cap or whatever you got to do. It's 1 through 13, okay? And I'll explain what all this means in a moment, but that you need this in order to move forward. Now, for this is only 1 through 13. I'm going to add a 14th. So number 14 is any other metal. I'll say it again. I'm going to add a 14th. Number 14 is any other metal. So these are all metals. Okay? So hopefully you paused that and you wrote that down. We're going to go back to the document here so you can see what I'm thinking. So here's the deal. Okay? I'm going to be referring to that list off and on, and what we got here is, wait a minute. I totally screwed this up. Okay. The example I did is actually a combo. Man, I need some coffee this morning. Wow. Okay, so that was a review on combo. Let's talk about singles real quick. A single, let's just get this thing out of here. We don't need that. All right. A single is a metal plus an ionic compound. Do you see where I goofed here? Now what happens is your products, I apologize for that, your products are going to be a different metal and a different ionic compound. No one caught me on that, all two of you that are watching this. Anyway, so this is a single, okay? You got a free review on a combo earlier. Now, what I'm talking about, that list of metals that I gave you a moment ago, I'm referring to this metal and the metal that's in this ionic compound. So let's do an example. Let's say I got sodium and copper 1 chloride. Okay? Now, this reaction is going to be possible because, refer to that list. Let's go back to that list for a moment. Sodium is number 4. Copper is number 11. Now, what you need to do is think of these as like UFC rankings. Okay, number 1 is the strongest, the best fighter, the one that's going to win every fight. Number 13, at least on this list, is the weakest. Okay, he's not going to win against anybody. He's going to lose against everyone. So lithium is the strongest, silver is the weakest. Now let's go back to here. Sodium is 4, copper is 11. Let's go back to this screen here. So, sodium is number 4. Meanwhile, copper is number 11. In order for this reaction to work, you have to picture this as sodium is literally trying to steal from copper. All right? So, sodium is going to steal chlorine. Copper is now going to be left alone. And sodium gets chlorine. Okay? That only happens if sodium is higher on the list. He's a higher rank. So sodium's number 4, copper's number 11. Sodium will win that fight and successfully steal chlorine from copper. Now, let's look at that list again. Actually, let's just do another one here. I'm going to make one small change. So I'm going to do sodium and potassium chloride. Okay? Now, we know sodium is number 4. If you look back to that list, let's bring that back up here. Potassium is number 2. Okay? So potassium in this case is actually stronger than sodium. So sodium can try all day, but he will never win a fight against potassium. So in this case, this reaction cannot occur because sodium will not successfully win. So your answer for this one is NR, meaning no reaction. There you go. Just saved you some time. You don't have to predict products. You don't have to balance the equation. No crisscross. You move on to the next one. That's it. That's the whole lesson for today. So let's adjust this camera here. All right. So let's do another one. All right. Trying to make it so I can sit comfortably because that's what matters. Let's say we got Connor, is this making sense? Anybody else that's out there, is this working for you so far? You got that list. You're going to be referring to that list for singles only. So again, Connor, give me some feedback if you're with me or not. All right, let's do another one. Let's say I got I don't know, lithium plus silver nitrate. Okay? Lithium is ranked number 1. Silver is ranked number 13th. So lithium can, no problem, steal from silver. So what you're going to get now is silver is going to be alone. That's why we call it a single, because there's always something that is single or something that's alone. And remember, the metals are just switching places anyway, so you're getting one of them things, okay? So silver's now alone. Lithium is going to be crisscrossed with nitrate. So when lithium and silver nitrate get together in a flask, in a container, whatever, they're going to mix together and react, and you're going to get silver alone and lithium nitrate as a new compound. And that follows this pattern of the metal plus ionic makes a different metal and a different ionic. All right. Now, that wouldn't always be the case. So let's say I have let's go back to this list here and just pick one that we know can work. All right, let's see here. I got my list up. Let's do something crazy. All right, let's do calcium plus lead 2 phosphate. All right, so I just wrote that down, and I got it here on my screen. So calcium plus lead 2 phosphate. Now calcium is ranked number 3. Lead is number 9. So calcium is definitely stronger than lead, and this can successfully happen. Now you got to do the crisscross with calcium and phosphate, but put lead by himself. So calcium and phosphate should get crisscrossed like that. Last thing you got to do is actually balance it. I'm going to put a 3 there and a 3 there. Done. All right. Let's do one more, and then since there's only 3 of you, and I think one of them is my wife, we will be wrapping this up soon, because this is literally all there is. And then I'll put an assignment up on Google Classroom that I need you guys to try for tomorrow. Okay? Now, tomorrow is Thursday, so we will be slowly wrapping this unit up by the end of the week for sure. So let's do one more example. I'll get you that worksheet on Google Classroom, and then I'll see you. Again, I will be up on this live stream again at 9, so if you guys want to kind of hang around and see what honors are doing, totally cool with me. And I'll open up the last part of that portion for questions and what have you. Okay, so it's up to you. Anyway, one more. Let's go back to that list so we can refer to it. I got it's a bunch of them here. So aluminum is a good one. Most of these charges you should know based on where they are on the periodic table. So I'm going to go down the list real quick and just tell you what they are if you're not aware. Lithium is a +1. Potassium is a +1. Calcium is a +2. Sodium is a +1. Magnesium is a +2. Aluminum is a +3. Now zinc, this is one of the first times we've seen zinc and its charge. We did talk about it in the previous unit, but I want to spell it out right now. Zinc is always a +2. Okay? +2. Iron is going to be 2 or 3. Lead is 2 or 4. Hydrogen, when it's acting like a metal, is always a +1. Copper is always going to be either a +1 or +2. Mercury can be 1 or 2. And silver is always a +1. All right, so hopefully you followed along and you were taking those notes. Rewind it, pause it, fast forward, slow down, whatever you got to do. Let's do one more. Let's say I got, I'm going to write this down, and then I'll show you what's going on. All right, let's see here. Let's go to this screen. All right, so there's my next reaction. Magnesium and hydrogen chloride. This is a hydrochloric acid. All right, so magnesium is ranked number 5. Hydrogen is ranked number 10. So they're going to switch. Now I'm going to get hydrogen alone. Now when hydrogen's alone, it's a diatomic, so I got to make sure I put a 2 there. That's something that you should know. Then I got to do the crisscross with magnesium and chlorine, and I get MgCl2 based on the charges. And then I got to balance by doing that. It's really that easy. Some reactions are going to happen. Some reactions are not going to happen. And it is definitely just a no reaction situation when the one metal is not strong enough to take the other. Looks like I'm having some buffering issues here. It's probably just my Wi-Fi. Comcast has been having all kinds of issues the past 24 hours. So tomorrow, when we see if I can actually make some adjustments on the quality, it might not be as nice looking, but at least it won't be so stuttery. All right, so that's that. I'm going to wrap it up here. And, yeah. All right, you guys. Cool. I hope you don't have any questions because I don't see any coming in. But take a look at the Google Classroom for the worksheet that you'll see shortly. All right? Cool. I'm going to go back to this screen. You guys can continue adding stuff to the chat if you like. But in the meantime, this is what you're going to be saying. All right, guys. Take it easy. I'll see you again at 9. All right, and excuse me. And we are live for the honors portion of this. Yeah, I've been experiencing some Wi-Fi issues in the past few minutes, so don't be surprised if the video is a little choppy or what have you, but I'm doing the best I can with what I got, and here we are. So, for the honors portion, we are going to continue our discussion about the moles and the mole of conversion units and things like that. So there's a little bit more that we need to talk about in regards to actual gases. So if you remember the mole roadmap, there's moles in the middle. On one side is mass, one side is rep particles, and up top was the volume of a gas. Now, we need to elaborate a bit more on that before we proceed on to the next portion. And I have on my other computer the actual PowerPoint that you would have seen in class. Now, you can't see it, it's over here. But I'm going to use it as a guide to kind of cover what we need to discuss. So, let's see. I got one person watching apparently. Whoever you are, please say hi so I can, know who I'm talking to. And let's get rolling. So, let's talk about volume of a gas. Now, we know that a volume of a gas is 22.4 liters for every 1 mole. So this we know is the conversion factor. Okay, so 22.4 liters is equal to 1 mole. All right, well, this information actually gets you a lot, and you can do some quick math here. So we're going to do a question, and I'm going to show you how to solve this question, and then you're going to get a formula, and this formula will actually be very, very helpful. So the question is, what is the density of krypton gas? Now, you don't really need to know much about krypton right there to do this, okay? We want the density. So let's figure this out, all right? So the density for a gas, well, density for anything is always mass and volume. So mass divided by volume, right? So we want to get something that's going to be in grams per liter, all right, for a gas. So that will get you whatever number you have associated with those units. That should be the density, okay? So here's what I want to do. I want to build the conversion factor like this. Sorry, I was pausing for a minute there. All right, so if I have this, which is just from what we learned earlier in the week, or last week, and I'm going to take this, and I'm going to convert moles to grams. So liters are going to stay the same. So when I do this and I get my final answer, it's going to be grams per liter. Now, to do this, you need to go to the periodic table. All right? Now, hopefully you have one there at your desk or whatever, but the one that I've been... So I need to have... I'm completely ill-prepared on this one. Let's see if I got a periodic table here. Hang on. All right, here we go. So for the mass of krypton, you got the periodic table there, whatever. I'm just going to leave it here. The mass of krypton is 83.789. 798. All right, so I just wrote that down. Let's go back to this thing. So the question is, what is the density of krypton gas? You know this to be true. You're going to start with that. You have 1 mole per 22.4 liters, and you're going to convert moles by dividing it out and switching it to grams. The units you're going to be left with are going to be grams per liter. You do the math, and you get the answer. That's really all there is to it. So what you can really do is make a formula out of this. So for gases only, okay, the density of the gas is equal to the mass divided by 22.4. Okay? That's it. So that's all I did here, right? This divided by that, whatever. All right, next, you can rearrange this and say the density times 22.4 is equal to the molar mass. So you got two formulas that are very helpful that you can use for other questions. Now, if you were to do the math, you would get the answer there. So my next slide would be all right, it's a question about halogens. Okay, you remember the halogens? They're that row with fluorine down. It says you calculate, you have one of the halogens, you don't know which one you got. You calculated the density to be 3.164 grams per liter. Which halogen do you have? All right, well, if the density is equal to 3.164 grams per liter, you're going to use one of these two formulas to figure out what the which halogen it is. So if you have the molar mass, couldn't you decide what the halogen was? Right? So all you're going to really do is take this density in the question and multiply it by the 22.4. And you're going to get something around 70 or so. Well, chlorine, being a diatomic, each one is about 35, so that would be times 2. That should be 70. Okay? So chlorine should have a density of 3.164 grams per liter. And you can actually go backwards and solve that. But this formula, or these variations of the same formula, is what you really need to know. So that is a continuation of stuff from last time. Now, on to new stuff as well, okay? I'm going to be putting up a worksheet on Google Classroom to practice what we just did and the new stuff that we're about to do. So this worksheet is not going to be graded for an actual Power School thing, but it will be something that you need to practice, okay? All right, so let's take a look at percent composition. All right, now percent composition is a thing where you're going to be calculating the percentage of each element in a compound, okay? And I'm talking to all of one person so far. This is going great. All right, so percent composition. It's going to be the percent by mass. So this is very simple. So let's say we had a very simple compound like water, H2O. If I say calculate the percent composition of H2O, you have to do a percentage for H and a percentage for oxygen. All right, you got to do it for every element in the compound. So every percentage is always part divided by a whole times 100. Okay? Now I'm going to be rounding. You will not be rounding when you do this on any meaningful assignment. I'm just doing this to get you through. Okay? So it's always, excuse me, part divided by whole times 100. And then you get your answer. All right? Well, the whole thing should be the whole for both, and it's by mass. So each hydrogen is going to have a mass of about 1. Each oxygen has a mass of about 16. So the whole thing should be 18 grams. And you're going to use that 18 for both. Now for hydrogen, I have 2 of them. Each one is worth about 1, so it's 2. Each oxygen is worth about 16. You do the math, and you get your percentages. Your final answer would have a unit of percentage, and you would give me 3 decimal places. So whatever you get with 3 places, you might have to make them zeros. It's entirely up to you. This is a very simple formula, a very simple thing to do. So let's give you an example. All right, let's say I have C3H8, which is the formula for propane. Okay, and the question says, what is the percent composition? Well, you got to do a percentage for carbon and a percentage for hydrogen. Okay, very straightforward. The mass of the whole thing will be used in both, and that's about 652. You're going to multiply each by 100. You get your final percentages, okay? Now, you have to account for every atom in this whole thing. So I have 3 carbons. So it's going to be 3 times the mass of carbon, which is 12.011. Hydrogen, there's 8 of them. 8 times 1.00794. Just get them from your periodic table. All right, nothing fancy. Do the math. And what you should be getting, because I got this problem worked out already. All right, you should get for the carbon 81.71%, and hydrogen's 18.29%. Now, when I did the math earlier, I did not give 3 places after the decimal. That's something you're going to want to do. You have to give me 3 places after the decimal, okay? It's just the way it is. Still only one person watching. So that's going to be our sig fig rule. 3 places after the decimal. I only give you 2 here, whatever. But here's how you check your work. Add them up. They should add up to 100, and this does. Okay, so I know I'm right. All right, next, there are a variety of other ways I could ask this question. So that's basically how you calculate the percent if you have the formula. Now, let's say you don't have the formula. Instead, you have more information regarding the specific elements involved, but not having the formula itself. So let's say I have a compound that's made up of 8.20 grams of magnesium and 5.40 grams of oxygen. I want to know what the percent composition of this compound is. You don't have the formula, so you can't rely on that. But you already have the masses of the parts. And if you add them up, don't you get 13.6? Shouldn't that be the mass of the whole thing? All right, so percent of magnesium is part divided by whole times 100. Oxygen is part, which is 5.4 divided by a whole times 100. And then you get your answer. So 2 different ways to do percent composition. Very straightforward, very easy, not very difficult at all. What you will be doing eventually is using this in as a conversion factor, and we'll do that tomorrow, all right? I don't want to throw too much at you at once. So we have the stuff that we did for the gases where you have the formula here, right? You need that stuff in the box. Density is going to equal mass divided by 22.4, or the density times 22.4 gets you to molar mass. And then we also talked about the percent composition where we did 3 questions. Okay, that's about what we would have done in class today, at school anyway. So that's that. I'm going to, on the Google Classroom, attach a worksheet for you to practice these 2 concepts, and we will start tomorrow's lesson with going over some of those answers. All right, so there were no questions. Only one person is here, and I have a sneaky suspicion that it was actually my wife. So, Tina, if you're watching, I love you. Thank you for actually, doing more than my students do. So there's that. I will see you guys tomorrow. We're going to be doing 8 and 9 a.m. If you're not going to be awake to join these live streams, that's on you. I can't help you if you don't give me any questions. So there's that. We're switching to 8 and 9 a.m. for the remainder of this week, just so everybody's on the same page. All right? Cool. I'll talk to you tomorrow. See you.